We are back for another couple hours. Interesting. Hey, Bet, welcome. I'm trying to think. Probably port the rest of the code in here, the rest of the losses. Probably ideal. Okay. Looking for training curves. Let's see what this is supposed to be. Okay, so episode length is supposed to go up. And then return starts very low. And okay, it's supposed to go up. So we are logging returns. So let's do let's figure out the extra weird reward that they added, and then we'll go from there. We'll do that. Is this it? Yeah, hold on. This is it. Okay. Okay. I'm pretty sure the only thing that we really need to do here is the additional loss. Yeah, it's gotta be here, right? Update mini bash. AMP ops. So you get the AMP ops. Then you do self.model. We do forward on. Nope, this is the wrapper. The only thing worse than debugging very convoluted code, particularly when it's not your own very convoluted code, is doing so half asleep. You need to catch up on some rest. Yeah. Eval actor, eval critic. AMP builder, network, and return net. Wait, then what the hell, right? Because I just saw this. Look, you give it batch dict, takes a dictionary, doesn't it? Eval actor, eval critic, mu and sigma. How the hell does this thing give you a dictionary? Oh wait, hold on, is this it? Here we are. Right here, this stupid piece of code. What the hell is this prev? They come up with some really freaking crazy losses here. But I think that all they do is disk agent replay. Apply. They concat these together. Just demo logic. Okay, so this doesn't look very bad. Yeah, this doesn't look very bad. So all I have to do here, it's just an extra loss. Now we do need AMP obs, AMP obs replay, and AMP obs demo to be recorded. So I need to get these into here, and then I can compute the loss, and then we should be good. Okay. Here's AMP obs, right? Extras. Ah, hold on, there's an AMP obs buff. Wrong file. Per AMP obs buff. And this isn't here. I don't know what the replay thing is. Let's see. Agent logic, replay logic. MPB get total count. Oh, so they're doing some bizarre thing here with replay. Yeah, we shouldn't care about this. We just need demo, AMP ops. This is not called. Actually, neither of these freaking make sense, do they? What's this disk loss then? I see. So one of these is just your data formatted the way that it is expected, and the other one is from the demo. Okay. So compute AMP operations. In order to push a PR, do I need GPG keys or can I? You can just, well, you don't push a PR, you submit a PR and then I approve it, but yeah. I don't know why you would need anything else. Who is this as well on Twitch? Is this someone I know from Discord or elsewhere? Oh, yeah, they like their processes. We hate processes. We like simple things. You know, there are a lot of things that smaller dev groups and small companies just do because big companies do them. Doesn't mean that you should do them because of that. So weird. This is. So they are in training. You fetch demos. Does this make any sense? AMP batch size. This looks really wrong, but I'm not positive. Hang on. How do they do this in? I'm not sure what you're PRing as well, but it's generally a good idea to, well, if it's a simple fix, then you're letting me know here is fine. But for bigger stuff, we manage a lot of dev on our Discord. And there are a lot of helpful people in there as well. It's about emulation.py. Okay. That's probably the most complicated file in the project. So, what specifically? Heading to M single N should be changed. Let me see. Is this just a bug? Do I have it as a dictionary? I think you're right. I think I do have it as a dictionary. Wait, this doesn't return the dictionary though. This is... No, wait, when you call observation space in petting zoo as a function, right? You pass it an agent. And, self-env observations. Oh, wait, hold on. Self-env. I see, because it's the internal... Should it be single observation space? No, that doesn't exist in petting zoo. Hey, Rishab. On. Yeah, I'm being careful here because if I just YOLO merge a thing here, this is like, this gets used by not any of our ocean environments, but this gets used by every single third-party environment. So, and ups, yes, okay. M signal, I see. Yes, that looks reasonable. Single observation space, M single. Yep, okay. That is fair. I'm in the middle of commit on this at the moment. If you PR it, I'll merge it, or I can just add it. Thank you for that. That seems to be correct to me. Yeah. Good catch. Thank you. Yeah, this petting zoo wrapper is kind of a pain. We need it because, you know, compatibility with existing petting zoo M's, but the dictionary interface of petting zoo really kills your performance on everything. So like all of our new environments, they use, we have our own API that's basically the gem vector API for our new ocean environments. And yeah, that ends up being way faster. We also tend to bypass the whole observation space thing again because of the speed, though that's not strictly necessary. Yeah. But we do have this for existing multi-agent TEMs. Okay, I was looking at... This is it, right? Okay, this does not call fetch anywhere. Just defines these three functions. learning is, it's called in is this the, what does this file even do? Okay, this is their trainer. This makes no sense to me whatsoever. But fine, this is how it's supposed to be. What got you hooked to coding as an undergrad? I was already coding for a long time before then. I've been coding since I don't know, 13 or 14 or something. And frankly, I don't know, because it's much better writing code now than when I started. I guess there's like a wow, I can just build stuff thing, even if you don't quite know how to do it when you are pretty new. But yeah, I don't know. Like programming is pretty much the only place in the world where you can just pull out your laptop and just build whatever the hell without capital requirements or teams or management. You can just do whatever, pretty much. What time? Um, probably like Junior year of undergrad, I did some stuff in vision and natural language processing first. So this needs to be, and that's such a weird thing, isn't it? The way this is, but we'll like, let me do this for a bit. Let me try this. So can I do something like this here? I should be able to. I might have to go, this might be .env. I mean, I started Neural MMO like my sophomore year of undergrad. It's a project that I've been working on in some capacity. I've been working on in some capacity for like the last 8 years at this point. I mean, I have my whole thesis on Neural MMO and why it's important to do stuff like that. Okay, this one should work. Okay, so this gives you demos. Isn't there supposed to be a time component? Like what? Streaming till probably dinner. I'm kind of confused at the moment because I'm working on something where like there's not It's very difficult to make forward progress here because the code just doesn't make any bloody sense. Um, I mean, there is a buffer, I guess. AMP obs demo buffer. Util. Yeah, this really doesn't make sense to me. I mean, this seems very wrong the way it is. Hang on. Times. Does it work on pairs or something? Yeah, it'll be more fun when I'm working on stuff where I can make progress quickly and have cool results. This thing is like, good programmers solve really important problems. Bad programmers make very hard problems for good programmers to then solve. Read this paper. Read, look at this paper. Is it just pairs? It still doesn't explain the way that they're doing their samples sequences. Ah, okay, so there is... Yeah, this is weird. I mean, they're clearly not sampling sequences unless I'm totally missing something. Motion times. The hell? How? I'm gonna go fucking crazy. What's the best reference to make multi-agent? Probably Snake. Snake is pretty simple. You know what? Let me check in here. Maybe this gives me a clue. This makes no sense to me. I gotta read the code. Like, if there were a license for programming, this code base would be cause for losing it. Thankfully, there isn't. But, like, holy hell, how do you even write this mess? And this is after Kyung has cleaned it up substantially. Well, maybe they're using it in a way that I don't understand. Okay, so there's AMP obs. This is just like the obs in the format that you're going to need. Fetch AMP obs demo. Okay, hang on. Maybe there's something here. So you have demos, and then you sample. Oh, I think they're doing a difference between the two. Do they reset the env? Self env reset. Look like it. It looks like they're not sampling trajectories. It looks like they're just sampling pairs. Crazy. I think it is doing a difference. That makes like no sense though. Oh, hold on. I see, hold on. I think I see. So, I think they're only giving you the goal state, the final state of the motion. Is that it? Maybe if I think of it this way now. Hold on, I think it makes sense. I think it might make sense. Okay, so if these are the goal states, so we sample a bunch of goal states, right? I'd have to see how they're used in the trainer, I think, right? Yeah, I think I have to see how they're used in the trainer. Yeah. Okay, this is AMP Obs demo. I just don't understand what they're doing. They're using PPO, but it doesn't seem like they understand what PPO is. I mean, this is like a weird hybrid thing. This doesn't even make any bloody sense. Hang on. That makes sense. Don't think it would. Man, I don't want to just sit here for the next hour and stare at this. I think I understand what is being done, but I don't understand how the hell the code does that, because the code is dog shit. You know, I just legitimately don't know what the hell to do with this. This is just such a mess. Let me think. Okay, the only thing that I can think to do that would work. Okay, I have to do it in the end layer. This is the only way I can think to do this. I don't even know if I'm right, but this is literally the only thing I can think of, so. There's gotta be a limitation to how bad freaking code can be that you have to deal with. Like, I mean, in some ways, this is worse than useless because there's a reference that exists to be matched, but it's like, this may as well be just an obfuscated binary with how shitty it is. Where do they go? Question mark. Cur AMP obs buff. Oops. Kyung is back. Do we get the first observation? Hang on. Eval. Side. All right. See. Hard code it for now. Simple. I mean, this is just obnoxious, but yeah, Kyung, it's going in the main clean puffer. I'm gonna branch this. This will be in a branch. There's no other good way to do this. At least as far as I can see, there's no other good way to do this. Yeah, it'll be custom clean puffer. It's not that many changes. We just have to add 2 things to this experience buffer. I looked at the code for the longest time. I still can't figure out what they're doing with AMP obs because it doesn't seem like they're training on sequences correctly. I can't tell. Their batching code sucks. So I think I know how to do it as long as we have good data coming out at the end. We have AMP obs, AMP demo. Now we have batch data. So now all I have to do is port over this loss. Let me see this loss. I also don't know what this other loss is, this bound loss or whatever. I couldn't figure that out. But if I find, where's this stupid thing? Skip bound loss, I think so as well. Okay, so here demo. Let's manage. Am I looking at the wrong file again? There we go. So then this gives you, and I don't know what the hell this, I don't know what this replay is. I have no idea what this logit is. But this comes from network. I don't know. Oh wait, because this is the discriminator. Is there no imitation law? Actions are bound. Okay. Self-model. I think this board is very different, right? Yeah. So here, I don't know what this is for, but you do. They have 3 different ops here, and I don't understand why they have 3. It seems like they should only have 2. It is the AMP format of the observation of what your current state is, and then the same thing for the demo. So I don't know what the hell this is, because I don't know what this piece is here. Oh, I'm covered by camera. Yeah, I don't know what this piece is here, so I don't know what this piece is. But this we can do, because this is just eval disk, eval disk. You call the model on both, and then so and then you do disk loss. Dude, how do you have this big of a loss? What's wrong with you? Disk loss, neg, disk loss, pause. It's negative 1 to 1, because it looks like they're trying to bound it to 0 and 1 here. But I think I can implement this maybe. I don't know, man. They're doing weird stuff. They're doing such weird stuff. Okay, so this is what we get. Is this from Morph? I want to make sure we're like actually building the right thing and not just building stupid things because they're like in the reference. But that should be the loss. There's regularization and penalty and stuff to do as well, but that's the base loss. Is there disk coefficient? Is this a thing? 5. Okay, so now this exists or whatever. Isn't there a reward term that you add as well from this? Or is it just a loss? There's a reward modification from this, right? Okay, so everybody's just using each other's garbage code. Great. Let's see what this does. I'll probably have to make, yeah, AMP obs buff. I'll have to do a few things. Just gonna push this stuff to Isaac Gym in a bit. The nice thing is this doesn't use fetch at all in the clean PufferL file. Oh wait, this is sequence data? Is this temporal data here that I'm looking at? What's up with this? Ten steps. Well, what am I supposed to do with that? Wait, that doesn't even make sense, because how can it be 10 steps? AMP ob should come from the current state of the simulator. How could you possibly have 10 steps? Right, this is literally based on your current state. And then AMP demo is none, which is just lovely. Zeros. Ah. So we gotta change that then, right? Wait, how the hell is it even possible? It's only 10. They're literally only doing 10 step. In like a continuous time problem, they're doing 10 step segments. What? That doesn't make any sense. Oh, wait, hold on, I don't need to do this. I can just let them do their stupid thing, right? And I can just do, for now, I can just set this to cur AMP obs buff, because that's a view. So I think that what we can do here, we can't call it just like this, not quite. Okay, well actually we'll put this in here. Okay, so on a reset, you reset this buffer, and then you do self dot AMP or demo IDX is 0, right? And then here we do plus equal 1. And then we do per AMP demo buff is going to be equal to AMP demo buff 0. Set this to 0. One. Okay, you do this, and then we do self dot per AMP. Well, we think about something like this. And now in here, AMP demos per AMP ops demo buff. And then what we should be able to do off of this is instead of getting this thing that makes no sense, which is getting all at once these trajectories. We'll get these that will actually line up. Presumably the M's can reset at different times though. Or do we just not, like, I don't know how this interacts with resets. Loss function. I don't know if that is the loss that you're showing me is actually the loss that they have. Does this reduce to binary cross entropy somehow? I don't think it does. $196, okay. So I had unrolled this without realizing. Wait, are they resetting individual environments every 10 steps or more frequently to handle this crazy demo thing? Don't know. Gotcha. Yeesh. Ah, I see. The only thing is that this gets called on reset now. So whenever you reset, you need to pick new ones of these. So actually, this should just be end by these. And then this should just be, I guess, self.all. I hate that they do this. Actually, it should be length of self. All end by these like this. Slice none. That should be a little faster. And not called on training init anymore. And this really doesn't need to be allocated here either. There's really no reason for it to be allocated at that stage. So this is garbage. There we go. It's a little better. And then we can avoid this confusing thing here where it seems like these are dynamic. This can go here. Okay, yeah, Kyung, so explain to me how this is supposed to work then if I have this wrong. Because I don't think it works any other way than what I'm currently doing it. So what they're doing, right, is they're calling fetch to get a batch of data all at once inside of train, right? And then that gives you your demos until you're finished with this batch of demos. And then they have some really weird experience buffer that makes it really difficult to track how they're actually matching up time steps for the samples to their buffer. And I actually have no idea if they're handling resets across environments at all. I don't think that they are, because I don't see how dynamic env time matches up to this. So what I'm doing instead is I'm just making it part of the environment, and it will just generate new demos for each environment whenever it resets. That's all I was doing with it. Because something doesn't match up here, right? Look. I still don't see how that's relevant though. Like whatever loss they're using, you need to make sure that you're actually taking contiguous segments, right? So I don't know how you control trajectory bounds otherwise. It seems way cleaner to me to just sample it in the end. Because I honestly can't follow what they're doing with their data. Just about this style. Isn't there a reward function as well, though? The demo uses the same format, right? It's the AMP demo. And regardless, I think you still need to match trajectories up. It's actually motion plus matching, right? But like, if I don't do this, right? So if I don't actually make sure that because I don't know how to match up the the AMP observations to the actual trajectories without doing it in the environment, right? Because all these are going to go into a big experience buffer, and the experience buffer, like, puts everything together flat, and they're not going to have the same trajectory length or anything. So once they're in there, I have no idea how we match up maps. I also don't understand how in the curve that you sent me, you have episode length increasing to like 80 or something if the animations are like, if it's only length 10 for the source data. Motion matching reward. How can it be if you're sampling new data in training? Are they loading the same data twice or something insane? Isn't the target motion in the AMP format? I'm happy to jump on a call if it's easier. This thing is ridiculous. Motions to be trained, resampled every 500 epochs? What the heck? As assigned. Well, that's what I'm doing here with the AMP ones. Is it not the same? Motion. Imitation observations. Position one previous frame. Okay, I mean, I can do that. Current and previous one frame. But then there's also a demo, isn't there? The AMP loss uses the demo. I guess the demo is the target, is that the case? So is it not your two previous frames? Demo is fake samples produced by the agent. That doesn't seem like it, is it? Like, this isn't produced by the agent. Right, this comes from PufferLib, doesn't it? This looks to me like it's loading like imitation replays or something. Yeah, so look, the loss here. So you have discriminator loss, and the discriminator loss is the sum of two components, one of which comes from, well, they concatenate this replay logic, which I don't know what this is. Maybe this is the previous frame. Fake sample, but it's concatenated with the real sample. The loss here is just agent logit, demo logit, and then this thing. So I implemented this portion here. The only thing I don't have is I don't have the replay logic because I don't know what it is. Like, I don't know what the fake sample is. Is it the previous sample? Is that what it is? The previous sample? Because I can get a buffer with the previous sample. But that doesn't seem right to me either, because the what's the discriminator doing? Isn't it just trying to figure out see, the loss function that you sent me on that is not what is implemented, so I'm confused. The discriminator is just trying to tell apart your current state from the demo state, isn't it? Or is it doing more than that? Compares a fake and a real value. But they have the demo in here. So in the code base for this paper, they have the demo in here. So I don't know if by real and fake, they mean demo and then whatever the hell the humanoid's doing at the moment. So you're saying it's this, but I'm looking at the code and this is not what I'm seeing. Well, look, this is, I mean, you have it right here, the discriminator loss, negative plus positive. Here it is right here, right? Oh, wait, and then they square it. Hold on. No, but this is different. This is for the logits. They're squaring logits. No. The actual loss is right here. This is binary cross entropy. So it's the sum of two binary cross entropy terms, is what they're using for the discriminator here. But I mean, either way, I apparently need the previous step, so I'll go get the previous step, I guess. I can do that. Oh, it's gonna be more complicated than this, isn't it? Shit. Yeah, this is so incredibly obnoxious. I think I can get it. It's just, it's gonna be tricky. So I'm going to have to change this a little bit because the buffer at the moment, I won't be sampling it correctly. Yeah, but the idea would just be to just have the environment make the current and previous observations available at every step. So we can just stick those into our buffer. And then we should be able to do stuff with that. Do I need this like difference anywhere else, Kyung? Because technically I could just hack it and I could have if I mask by the duns, I think I can just like shift the experience buffer by 1 and do it that way. But I suspect we probably need this in other places, or no? How many freaking losses do they have? Well, also, why are we even looking at these papers? What's Morpheus? Let's see what their losses are. Is this the AMP obs right here? Here's the binary cross entropy, presumably. This is just PPO. This can be done in the environment. Isn't this thing simpler? This is obs. Wait, this doesn't even use the freaking demo, does this? No. State sampled input pose. These are distinguished by different hats. This is the new discriminator. It's already implemented. The main thing I'm worried about here is not having, we need this data here. We need this data set. Where did the demos even come in at all? Simulated pose. I guess input pose is going to be the demo. So had is the demo, I guess. Test data we use as a subset. Was the format the same? Yeah. Simulated pose x hat. Okay, so then the input motion refers to the demo data. So that's here. So this is this first loss. And then you have P. Okay, so you have this loss. So this is done in the environment, right? But what I don't understand is it looks like you're loading data twice for some reason. Motion discriminator. Okay, so this is not right here. This is not. Sampled input state and simulated pose. Okay, so I don't see any difference between current and previous state. I don't see any difference between current and previous state at all in here, do you? This is what I mean with like making sure we're doing the actual correct one, because otherwise we're wasting our time. So let's not waste our time on that. Because here's the thing, right? We are already loading the data in the environment without having to call this stupid task function, whatever, from the trainer. We're already loading the data in the environment in order to compute the state, right? Because the state here, we have the difference between the demo and the simulated state, right? So we'll just put the demo state into the experience buffer, as I was starting to do already, except we're going to have it even easier than that, because instead of having to hack the task sampler, we'll hack the one that's actually already integrated and timed correctly with the other one, right? There should be a different load data. Where is it? Physics step. Do we have where the is the imitation data the AMP data? Hold on. We don't even have multiple different states, man. Yeah, we don't even have multiple different states. So we're just totally spinning our wheels here, like getting confused with all these stupid, complicated previous work papers, when the thing that we actually care about is not that complicated. Look at this. Right? This is the state. Yeah, the data format to get this is a little bit annoying, but like, we have this buried in the code somewhere already. Because this is just joint position, joint velocity, angular velocity, right? So we have this. This is just component-wise loss over that, right, with different weightings. This is computable from this as well, just from these four terms, as this reward term. This is simulated pose. The hat is simulated pose. Tilde is imitation data. This is also done only on the state. Imitation is implemented in compute reward. Okay, so the motion lib cache is then the thing to understand here. I think I have the clarity back of what we need to do because the morph paper is not that bad. Honestly, it's the fucking reference papers that are just dog shit. So complicated, and their code sucks. Yeah, this doesn't involve any difference of states. This doesn't involve anything that requires us to resample motions from the trainer, right? But the discriminator doesn't involve a difference of states. Look, this here, the tilde, is the imitation data, right? And then this one here is just your reference state. So this here, this thing, you have this for your simulated data and you have this from the data set. And then this, you take a difference here. There's never a difference of like state to next state. It's only imitated data to simulated data. So the thing from the previous paper is just not relevant. Because they replaced the motion discriminator here, right, solely on physics simulated. Yeah, okay. So this we can do, because we're almost there as is. I have this loss in clean puffer. You say that we have the rewards, right? Do we have this one as well? No, we don't have this one yet. But this one gets added in. This one has to get added in. Where's RE? RM, RE, okay. So RM and RE come from the environment. So these two are both in the environment, right? Which you've said that we have imitation and energy. Yes, perfect. So this one, so there are two pieces left, right? There are just two pieces left. And they're not that bad because all we need to do is we get SA, which one? SA tilde or SA hat? Well, we get both of them, right? One of these is observation and the other one is the reference observation from the imitation data. And then this has to go right. Okay, I think we've gotten progress here because I think I am clear on what to do now. Okay, so the only thing that's slightly annoying, right, is I have to do it here before we compute JE. But that's not bad. I'll just compute it for the full batch right here. Maybe I have to move JE down. Maybe I have to like recompute JE or something. I think we have to recompute JE in the loop now is the only thing, but we have the Scythenized version, so we're fine. So this JE computation will be moved down into the loop here. We'll put it like here-ish. And the discriminator reward will go there. And then we'll compute the discriminator loss, and we should be done. And then the only thing we got to worry about is the data difference. All right, I'm gonna go grab dinner. I'll be back in a bit, and I'm going to try to get this implemented for you tonight, Kyung. If you can figure out, just so we're clear on the data and we have the data loaded in the correct format, then I think we'll be good, and we'll have like the whole rest of the time to run experiments and to get the result to match. So I'm gonna go get some food. Let me just check Restream in case anybody's been watching this. There are a couple people watching me talk to my side monitor, which is amusing. So for those folks, we normally do much more interesting RL around here. We do ultra high performance on a variety of different environments. You can play with some of them right here on the website. If you're interested in supporting this work for free, check out the GitHub, check out the code star, the repository. That really helps us out. And other than that, you can join the Discord or follow me on X for more. Thank you very much, and I will likely be back for an hour or two after dinner to